David, great to be here together today.
Refik, it's great to see you. It's great to talk to you again. We're here to celebrate the intersection of art and technology.
Yes, happy to. First of all, grateful to be here today for such a meaningful day. And also, as a media artist, I always feel that I am on the shoulders of many giants, like Lillian Schwartz and like yourself and many engineers, researchers, people who are finding the near future experiences for humanity. So as an artist, I'm inspired from science and technology and have been practicing with data as a pigment and working with machine learning algorithms to create experiences in immersive environment, architectural scale, or I'm calling it data painting since 2018 and 2008, sorry, so last 13 years. And the idea of like, can a machine learn? If it can learn, can it dream is a kind of a question I'm trying to follow. Last, especially 5 years, me and my team, I'm not alone. I represent also my studio in Los Angeles. We are 14 people, can speak 14 languages, represent 10 countries as a team of thinkers and artists and designers. And we are trying to follow the future that you and wonderful researchers are creating for us to imagine.
That's fantastic. I think that my field, I'm coming from the technology side. My field is 3D computer graphics. This is, has always been a field that's at the intersection of art and technology, and it's technology in the service of the creative, and so it's so inspiring to see artists like yourself doing this amazing work with the things that we build, whether that's the hardware that goes into a graphics card that goes in the computer, or the algorithms that we develop to take all of this data and train on it and generate something that is inspired by, that is sort of modeling all the data that it's seen. And I think this is a super appropriate place to have this conversation because, of course, one of the real progenitors of this was Lillian Schwartz and the incredible art that she did that broke these boundaries and sort of created this fusion for the first time, publicly to many people.
I was also as a student at UCLA as a design media art student. The very first thing as a media archaeology class, the first thing that I personally inspired was her incredible 1968 EAT research and also the MoMA exhibition. I mean, there were like many artists like myself who have been thinking with technology, code, algorithm, computation. I think that's kind of this origin moment, I guess, inspiration for many people. I
think that I'd really love to dive into one of the things you said, the idea of sort of treating data as a pigment, because that's something that I'm very excited to sort of talk about and think about is the way that sort of gathering data is how you make art, is the first step of how you make art. So can you talk us through a few of the pieces that you've done, and then let's and how you've used data in this sort of innovative way?
Because when I think about data as a pigment, it's of course not a material we know just in life, in a physical quality, but it's light as a material. But what is inspiring is when algorithms and computational imagination and computer graphics, they all come together, at least in my mind, as a creative thinking, they suddenly start like emerging into new forms. First of all, for me, data is a form of a memory, which can take many forms and many shapes. And when we think about light as a material, such as projection, LED technologies, and screens, and when the computer graphics come together, they have this new symbiotic relationship. For example, the signals around us, the computational research going inside the machine, AI research, or wind patterns, temperature, Wi-Fi, Bluetooth, actually everything that we can compute or quantify, I think can become a pigment in this imagination.
In many ways, what's exciting is that the artist in this form is a curator first and foremost, right? You're thinking about, you're gathering the data that you want to use, that you want to then pull together. And this fits so well with how artificial intelligence and neural networks, which is really the frontier right now of my field of so much of computer science, that's how they work, right? You create a training set. And that training set, by selecting your training set, by figuring out the criteria, and then going out and gathering it, often with enormous sort of manual effort to gather a training set, you build this. You have curated this collection that then you sort of turn the machine loose on, and see what happens. And I think that's one of the things that I find really inspiring about some of the work you've done, especially a recent example would be your work with ocean photographs, right? Photographs of marine life essentially, and creating this piece that people can then explore themselves. I find that just such a fantastic use of the GAN algorithms that we've developed for neural networks within our research.
Thank you very much. First of all, literally your research, specifically style GAN, PG GAN, pretty much NVIDIA's incredible generative adversarial network research is one of the most inspiring research for me and my team, because honestly, if a one-day machine can dream, I feel like it's exactly what it could dream. And when I show the results to friends and families and people who are know any contextualization of technology, they even sometimes say it feels like I'm remembering a moment in life. These are really very poetic moments when a human and a machine interact.
It's important to remember, of course, that all of us are standing on shoulders, and the style GAN work that you referred to is one of the prouder accomplishments, and it comes from an incredible team of researchers in Finland who have. What's neat to think about is that those researchers took their inspiration in turn from art, in particular from this work that was done earlier by Gaddis and others on style transfer, which was realizing that we can sort of separate out the style of a painting, for example, or a sketch from the content, and actually use neural networks for that. So there's this kind of recursive beauty to it all, right? So the researchers have been studying, ways to transfer style, artistic styles, and think about them in a separate way from the actual content of an image. And that has developed into this algorithm that we call style GAN that you've built so much of your stuff on to do these incredible new pieces of art. So it's a virtuous circle.
That's absolutely very true. It's a very childish baby dream. When you discover a new thing in nature, calling your friends and families, I found something new. That kind of a feeling, a very humanly feeling of discovering and innovating a moment. And we also again, thanks to the incredible openly shared documents and details of these GAN algorithms, we were able to create a kind of another software that allow us to fly real time in latent space and look for the patterns. And that was another serendipity. For example, from the flowers, we have around 70 million flower data that was learned and turned into this beautiful flower AI, flower GAN. And suddenly we were recreating these beautiful creatures that are from nature, the beauty. And every time that we do this latent work, we are discovering new patterns from nature evolving. Or the landscapes, the old national parks in the United States, when we recreate these all beautiful patterns of nature. It's just kind of appreciating the beauty of in life, I guess, in certain memories also, in a poetic way, also enjoying the cutting edge science and technology. It's really inspiring to imagine together.
So let's dive into the style GAN algorithm a little bit more. Tell us specifically about one of the works that you've done that's been sort of inspired by and builds on the style GAN algorithm. I'd love to hear some of the technical details as well as the inspiration.
Yes. So again, I think if a machine can learn, can it dream question, very naturally led on to the style GAN's incredible opportunity for creators. So last 5 years, we collected more than 5 petabytes of raw data, and we trained more than 100 AI models that look at the different information, mostly space, nature, and urban focus. Cities like Stockholm, London, New York, Los Angeles, Istanbul, and so on, or nature, landscapes, water, clouds, or beautiful creatures, underwater world, or space like Hubble telescope for Mars, and MRO telescope or ISS telescope. So in these 3 domains research, we created different projects. For example, machine hallucination was an immersive environment that created by 18-channel projection, where we use also cutting-edge RTX GPUs and reconstructed more than 8 IMAX resolution immersive room, where the people were stepping inside the mind of a machine in an immersive space.
So I just love the concept of kind of building dream and what does that seem like. So please tell us more. That I want to hear more about the Disney Hall project.
So for this project, we specifically focused the question what a memory can be for a building. And thanks to LA Philharmonic Archives, we digitized entire image archive of the institution, 15 years of every performance, every single document, and video and an image archive. And we trained a PG GAN algorithm, which is NVIDIA's wonderful research that was very early steps in 2018. And we were able to take what machine learned and project it back to the building as a skin to celebrate the 100 years of the institution. And to make this happen also, we use 42 channel projectors. And to connect 42 channel projectors, we also use cutting edge computer graphics, specifically mini GPUs together, NVIDIA GPUs together in multiple servers. And we sync them perfectly and achieve a kind of a light layer on top of the beautiful facade of Disney Hall. And what another, I think, meaningful part of the project was, while it is exploration of in architecture, AI, and neuroscience or near future science fiction experiences, the reality was it was a free public art, a free for everyone, open to anyone and any age and any background. And I think making art and science and technology accessible to humanity through the arts, I think has this very powerful moment. And when you see like everyone coming together around the building and enjoying life in public space, that's a really moment that you can touch science fiction, but it's there next to you.